Hello everyone, I'm Sir Saeed here. I'm with a new paper, and this paper is 9702, paper 11, and it is October November 2022. Without wasting the time, straight away I'm going to start from question number 1. In this question, what is needed to accurately represent all physical quantities? The accuracy is important here. So a base unit as a number, no, it is not necessary to have a base unit. A unit, a number expressed in standard form, no need to write in standard form to improve the accuracy. A unit and a numerical magnitude. Numerical magnitude is actually the number which is required while representing some physical quantities and with some units. Yes, it is making sense. And SI, no need to write SI unit to get the accurately representation. So option C is the correct one. Here, a voltmeter is connected across a resistor and the voltmeter reading is 3.6. What could be the current in the resistor and the resistance of the resistor? So the current and the resistance are given here. So V is equal to IR. We just multiply current and resistance. If the answer is 3.6, that is the correct one. So in question number 2, the correct option is D. So if we put the value here, D is 15 micro 10 is per minus 6 ampere multiplied with 240 kilo means 10 is per 3. So multiplying with this, the answer is 3.6 volt. Now in question number 3, a formula is given. It is G is equal to 2S by T square, and you have to get the percentage uncertainty. So in this formula we have the power for T, so you have to write the power factor here. To get the percentage uncertainty, the power of T is 2, so 2 multiplied with the percentage uncertainty of T, that is 3, plus the power of S is 1, so 1 is multiplied with the percentage uncertainty of S, which is 2. 2 is a constant here, so while getting the percentage uncertainty, the constants are always ignored. So 8% is the correct answer. So option C is correct. Moving towards question number 4, a simple question which is a vector quantity. Definitely momentum is a vector quantity. Its formula is P is equal to mv, and the direction of the momentum is similar to the direction of the velocity. Speed, temperature, and Young's modulus are the scalar quantities. Moving forward towards question number 5. In this question, a particle accelerates from rest. It means the particle is going to start its journey from rest. The graph shows that the gradient is positive and uniform. It means the gradient shows that the acceleration remains constant. This gradient is uniform, means constant. So acceleration is constant. Look at these graphs. These are not the velocity time graphs. These are the velocity acceleration graph. In option A, B, and C, in all these three options, the acceleration is changing, but here the acceleration is constant. So option D is the correct answer. Here in this question, the parachute is going to jump for 120 seconds. The velocity time graph is shown. Approximately how does she falls before opening the parachute? So here, this is the point where she opens the parachute. So from this starting point, initially the velocity was 0, and the velocity is increasing with the decreasing rate, and at this point the velocity become constant, the constant of the terminal velocity. Then at this point the parachute is open. So this distance is in fact required. So while finding the area here, this is 13 second, and if we have to write it like this one, initially find this area. So this is 60, means to get this area we have to multiply 60 with this 3 to get the area. And to make it a little bit easier, have this triangle, then add the area of this triangle, that is half into 60 into 10. By solving this, the area is I have already solved, this is 480 meter, but this area is missing, so it means the actual answer must be a little greater than 480. So option B is the correct answer. You can solve it more accurately by dividing it into further small areas. The answer will be close to 570. Moving towards question number 7. What is the definition of the linear momentum? So linear momentum is P is equal to mv, means it is the product of mass and velocity. Velocity product of velocity and mass. So option C is correct. In this question number 8, there is a mass of 0.2 kg suspended as shown here, and a second mass of 0.1 kg is suspended from the thread with this mass. The arrangement allowed to come into a static equilibrium. Static equilibrium means its forces are balanced, and then the thread is cut out. So initially the force acting on this system is the force which is equal to the weight of this lower mass. It is acting downward, and same force is acting upward because it is in equilibrium. So to get this force, W is equal to mg, the mass is 0.10 multiplied with 9.81, and its answer is, by solving, 0.981. 0.981 Newton. So this force is also 0.981 Newton. Now you have immediately after the thread is cut, what is the upward acceleration of this mass? So the upward acceleration is because of this force. Initially this force was balanced, but when the thread is cut, this is the resultant force which will move this mass upward. So while getting the acceleration, the only relation is for m, the force is 0.981, which will accelerate the mass, that is 0.20. So by solving this, the answer is 4.9. Yes, 4.9 meter per second square. So option A is the correct answer. Again, this whole system was in equilibrium. The force acting on this mass, which has to be accelerate upward, is equal to the weight of this lower mass. So when this thread is cut, this upper mass will accelerate upward with the acceleration of 4.9. Moving towards question number 9. Okay, theory question. Okay, now we have a snowflake and a raindrop in the still air. Means there is no air blow, but we have this snow and air drop. This is snow which is filled, and this is a raindrop in air. Raindrop. It's there. two forces are acting downward, that is because of their masses, because their height is same from the ground. Okay, the snowflake and the raindrop contains the same mass means the same downward force, that is this W, which is same in both cases. Assume that there is no evaporation. Okay, means there is no variation in the mass. Also assume that for a given speed, the drag force acting on the snowflake, there is a drag force, this one FD, there is a drag force on it, this is also FD. The drag force acting on the snowflake is greater than the drag force on it, means this drag force is greater. Okay, so the drag force on the raindrop is smaller. Which statement about the snowflake and the raindrop is correct? Actually, both these masses will get the terminal velocity when the down and the upward forces become equal. So here, the upward force, the drag force is already smaller than this, so it will attain the terminal velocity, and these two forces become equal with each other earlier than this one. So look at the statement. The raindrop takes more time than the snowflake to reach the terminal speed. Means if the drag force is greater, it will quickly attain the terminal. Means the raindrops take more time because it is smaller. So in terms of time, if we solve in terms of time, means greater the drag force takes shorter time to get the terminal. So here the drag force is smaller, so it takes long time to become equal to W. That's why option A must be correct. So the raindrops take more time than snow. Okay, no, not correct. Definitely their terminals are different because the drag forces are, they take the same amount of, no, the time is definitely different because it is falling in air, and the drag forces are different as well. So the raindrop takes more time. It means the snowflake would take less time to become equal, means more the drag force, quicker the terminal velocity to attain. Now question number 10, we have these two masses attached with each other. On the horizontal surface, the compressed spring is there. When they are released, the trolley lost contact. The trolley of the mass 2 kg moves to the left, so it will move in this way, and its speed is 2 meters per second. And definitely this will move in opposite direction. So the mass is half, the speed must be double to have the conservation of momentum. So if this is 2, the velocity of the smaller mass must be 4. So the momentum is equal and opposite on both sides. Mass is half, speed is double. How much elastic potential energy was stored? The elastic potential energy stored in this spring must be equal to the kinetic energies of these two trolleys. So elastic potential energy EPE is half mv square. M is 2 and v square is this one, that is half mass and 4 square. So I'm solving this one. 4 plus 16 by 2, 4 plus 8 is 12 joule. So the correct answer is 12 joule. Moving forward, question number 11. Okay, try to understand this question initially. There, a square board of a side x. The side of the square board is x. It's equal on both sides. Hangs freely from a nail. This is the point where it is hanged. And the board has a uniform thickness and made with the same material, means having the same densities. The second square having length 2x and same material, same thickness, each and everything is same. Now nail P and Q are at the same height, means initially these heights are equal. These heights are equal. Now what is the vertical distance between the position of center of gravity of the two boards? Means its center of gravity is this point and its center of gravity is approximately this point. Now you have to find this distance. This distance d is required. So if we find this length, this length, and make it half, we can find this height. And if we find this length and make it half, then we will be able to find this length. By subtracting these two lengths, we will be able to get this d. So here for this board P, these two lengths are perpendicular with each other, so straight away we can apply Pythagoras theorem to get this distance. This distance is, say, P. This whole distance is, say, P. This whole distance is, say, Q. So to get P, this is x square plus x square whole under root. So this is 2x square whole under root, and you may write it as under root 2 of x. For Q, we have 2x square plus 2x square whole under root. Should be written like this one. So it is 4x square plus 4x square, means it is 8x square whole under root. So this is 2 under root 2 of x. 2 under root 2 of x is 8x square. Means you may write it as, just to get, it is 4 into 2 x square. So by having the square root, it is 2 under root 2 and x. Similar. Now these lengths are required, so by dividing them, under root 2x by 2 is this length, which is the bold one, and 2 under root 2x by 2 is this length. So we are going to subtract these two lengths to get the answer. It's cancelled here. So under root 2x minus under root 2x by 2. So by subtracting, this is 1, this is half, so answer is half. Under root 2x by 2. This is the answer, but here the answer is, this is wrong. So we have to check whether this answer is equal to x over under root 2 or x under root 2. So just make it a little simple, like under root 2 over 2 into x. We may write it as under root 2 divided by under root 2. Here we may write it as 2x over 2 under root 2. When we solve these two, the answer is 2. So it is cancelled and it is x over under root 2. This answer B is the correct one. It is taking a little time because I'm solving it slowly to get some understanding and writing all the steps that you make. If you have the concept that how we can solve it, then you make it shorter. Uh, for this smaller board, we have to find this length, and for this bigger, we have to find this length. By subtracting these two, you can get the distance between their centers. Quick. Moving towards question number 12. Here, for question number 12, we have to write whether it is in equilibrium or not. So, to write the conditions of equilibrium, we have two conditions. The first one is that uh, the sum of masses on the body is zero, means the upward and the downward forces are equal, the right and leftward forces are equal. And the second condition is that the sum of all the moments is zero, means the clockwise and anti-clockwise moments must be equal to zero. Here in these options, the sum of upward is 2f and the sum of downward is 2f. Okay, the sum of 2f and f, so it is wrong. And sum of upward, the sum of downward, okay, fine, these three are fine. But in this case, these two forces are not going to have any rotational effects, but this is anti-clockwise, this is anti-clockwise, not balanced, so it is wrong. Here this is anti-clockwise and the clockwise moments definitely same, and the sum of up and the downward forces are equal as well. So option A is the answer because it shows the complete equilibrium of the body. Now for this question, this is a rod having a negligible mass. Its length is 75. The rod suspended from the fixed point over there. Yes, by having a string, the end is X, the object have 11 kg. By string that is attached to the rod is a distance of 25 OK from the end X. Which vertically upward force acting at this Y? So a force at this point is required, which make it horizontal, means equilibrium. So if this point is considered to be the pivot, then this force will move in this way and this force will try to move in this way, means the clockwise and the anti-clockwise moments must be equal. So for clockwise moments, this 11 kg, that is 11 into 9.81, this force is multiplied with this perpendicular distance 25, and here this distance is 75 into F. I'm not going to convert the units from centimeter to meter because the units are going to cancel on either side. So by solving it, it's solved here already. This is 36 Newton. So option C is correct. Moving towards new question. In this question, the density of water is given and the density of grass green is given. Water is added in a measuring cylinder containing 40 centimeter cube of grass green. It means here 40 centimeter cube of grass green is here. The density, so that the density of the mixture is 1.1. Water is added inside. There's a water which we add over there. This is water, and the density of the mixture is 1.1 grams per centimeter cube. Assume that the mixing process does not change the total volume. Okay, what is the volume of the water added? So this is the water which is added inside. So initially we have to write density is equal to mass over volume. So the total density of the mixture is 1.1, means it's total, and this mass is total as well, and this volume is total as well. So the density of the mixture is 1.1 grams per centimeter cube. You have to write the masses. The mass m of water, the mass m of glycerine, the volume of water is say V, which is required, this one, and the volume of the glycerine is 40. So you know that the density is equal to mass or volume, then mass is equal to volume into density. So for water, mass is volume V into the density of water is 1. Here the mass again is equal to density into volume. For the glycerine it's 1.3 into 40, and here it is V plus 40. So by cross multiply and by solving you can get the value of V. I have already solved this by using the calculator to save the time. The answer is 80 centimeter cube. So the answer is D. In this type of question, this is the trick. When the mixture is given, then you have to write the formula of density, which must be equal to the total mass over total volume. When the density of the mixture is used, then you have to write the ratio between the total mass and the total volume. Okay, moving towards question number 15. Okay, in this question, look at here. This is a box on the surface of the sea, and then this box is going to sink inside. The box begins to sink, become totally submerged deeper into the sea. The box sink, the lower face is always parallel to the surface. Okay, got it. Which graph best represent the variation of the upthrust? Okay, upthrust is because of the change in the pressure. So when it is inside, this height is same always. So the pressure difference is same, means upthrust is same. Upthrust is same because the upthrust is due to the pressure difference, and this height is same. The pressure difference is same, means the upthrust is same. So this question is wrong. Thrust is changing, and but here the upthrust is changing as well. But look at here, these two. It's looking that the upthrust is constant here in B, but when this box was moving into the water, means not completely submerged, means it was partially submerged, like when it was somewhere over here and then the somewhere over here, means it is going inside. So it means there is a variation in the upthrust because there is a variation in the height inside the liquid. That's why initially the upthrust is going to increase and then remains constant. So option C is correct, B is wrong. Question number 16. Initially the spring was unstretched like this one, the mass is put on it, which means it's compressed now. Now we have two things, that it's compressed means it must have elastic potential energy stored inside. Which statement describes the change in energy of the spring when it's compressed? Here in all these four options, the potential, the gravitational potential is also mentioned. The height is definitely decreasing. It means the gravitational potential energy is also decreasing. So the spring gains the potential, no, wrong. Gains gravitation, so these are wrong. The spring loses both the gravitation, no, it's lost the gravitational potential but gained the elastic potential because of the compression of the spring, so it's wrong. Definitely it should be correct. The spring losses gravitational potential energy because the loss in the height, and the gain the elastic potential energy because the spring is compressed. So option D is correct. Here for this question number 17, a man of mass 75 ran up the staircase consisting of 30 steps. It's like this one, 1, 2, 3, 4, 5, 6, 7, and 30 steps. Each step has this height. It is 20 cm. So to get this whole height, we have the vertical distance like this one. So to get the whole height, we have to multiply this 20 with the number of steps, that's 30, to get the stress. Anyhow, a man takes 7 seconds to run up from the bottom to the top. What is the average rate of increase of GP? Whenever this word rate is involved, means there must be a time inside. So the power is required. To get this power, the potential energy over time is to be required. So the mass is 75, G is 9.81, then and the height must be 20. This 20 is in centimeter definitely. So 20 into 10 is per minus 2 multiplied with 30, the number of steps, divided by 7.0. So by solving it from the calculator, we have already solved it somewhere. Yes, it is 630. So option C is correct. Question number 18. In this question, for the alpha particle, you have to write the speed. So the kinetic energy is half mv square. Kinetic energy is 2.2 into 10 is per minus 13. It is half. So to write the mass of the alpha, you know that the alpha is like the helium nucleus. So mass is 4 multiplied with 1.66 into 10 is per minus 27 v square. So by solving through calculator, v is the answer, that is 8.1. Yes, it's C. Yes, it's C. Okay, the identical springs are joined in the 4 arrangements. Have in all these arrangement, which arrangement have the same constant, that is K. So you know that while getting the combined spring constant, it is like opposite to the resistance. Like we get the combined resistance of series and parallel circuits, it's opposite to get K. So here we have the K become half, here the K become double, but in this option C, this K and this K, these two K are in series. So when we solve it to make it like this one, in series it become K by 2 and it become K by 2. So now they are parallel, and the parallel is straight away going to add, it will give you K. So option C is correct. You may try on all these others as well. The option C is correct. In this question number 20, an unstressed spring has this length. Unstretched means it is the original length of the spring. It is like this. Original length is 2 cm. Spring is then stretched within the elastic limit. Okay, it's stretched and within the elastic limit here, by applying some force on it. The force is 1.5 Newton. The elastic potential energy stored in the spring is 0.045 joules. What is the stretched length of the spring? It means if we get this extension E here and add this extension into the original length, we can get this stretched length. This stretched length is required. So you know that the relation is energy, that is half F of E, because it is within the elastic limit. So 0.045, that is half 1.5 into E. So this E is not the answer, because we have to add this E into the original length to get the stretch length. The answer for this E is 6. So by adding this 6 into 2, the answer is 8. A signal generator, amplifier, and the loudspeaker are used to produce the different sound waves in the air room. The relationship between the properties of these waves are investigated. Okay, the simple wave properties. Which relationship is not correct? Not correct. The amplitude is proportional to the wavelength. No, it is wrong, because this amplitude and the wavelength and the amplitudes are nothing to do with each other in terms of proportionality. So straight away this is the correct answer. All these must be the correct one, because not correct is required. The frequency is inversely proportional to wavelength. Yes, we know that for the constant speed, f and lambda become inversely proportional. Intensity is proportional to the square of the amplitude. I is equal to k square, and time period and frequency are reciprocal. F is equal to 1 over t. For this question number 22, what is the frequency? So f is equal to v by lambda. You know that it is 340, and the wavelength is from this point 0 to 0.5, and or from point 2 to 0.7, whatever. It means it's the distance from one compression to the other compression. Should be 0.5. So 0.5. The answer must be 680 Hertz. For question number 22, it should be B. Yes, it is. Now for question number 23. Here in question number 23, this is actually a transverse wave in the rope at time 0, and a wave is traveling from left to right. The time period is this one. From t0 to 2t, you have to show these graphs. So we have to write the relation for this one particle. So you know that for these types of waves, all the particles inside are moving downward like this one, and the particles are moving upward over there. This is the basic physics, we know that. So it means this particle is initially have at a 0 displacement, means these two are wrong. Initial displacement is 0 at the center, and then this displacement increases and then becomes 0, and then increases, becomes 0. So these two are looking correct. Both have two cycles like this one, but the actual confusion is this particle is going to displace downward initially. So the direction of the displacement is initially downward. So this is wrong. That's why option B is the correct answer. Question number 24. A jet aircraft travels at this speed, v is the speed of the sound. The aircraft directly approaches. So this is some type of aircraft. This one. This is aircraft moving towards the observer, which is at rest, means it is stationary. Its speed is 0.80 v. This is the speed of this jet, while the speed of sound is v. The frequency of the sound emitted is 100 Hertz. Which frequency does the observer here? Means the observed frequency is required. This is observed frequency, v over v plus minus vs into f. And you know that this jet is approaching towards stationary observer, means the observed frequency will increase. The observed frequency will definitely greater than 100. When this f naught increases, it means this value should be decreased, so we put a negative sign here. It is v over v minus 0.80 v into 100. So by solving this, the answer should be, okay, you may solve it like v 100 by subtracting these two. This is 1 and 0.8. It should be v 0.2. So this is your answer, 100 by 0.2, and this is 500 hertz. So option D is the correct one. For question 25, the telescope detects and analyzes some electromagnetic radiation of wavelength 2 cm. 2 centimeter is a long wavelength. So here we have the microwaves, the optical telescope. The optical telescope means the telescope in which the visible spectrum is required. Radio, the very long wavelength. X-ray, the very short wavelength. So microwave is the correct answer. Two waves of a same type overlapping of the waves. When does the principle of superposition apply? Superposition apply means two waves are going to overlap with each other if they have same frequency, traveling in the same direction. Interference is produced. Same frequency, traveling opposite to each other, the stationary waves are produced. So there is no condition about their amplitudes and directions and frequencies and things like that. So always you can get the superposition when you have the overlapping of the two waves. So moving towards next question. It's question number 27. Yes, it is. Here the stationary wave is produced here, and you know that at the close end we have nodes. So just to get some understanding, it is actually the sound waves. So here the displacement of the particle is 0. Here the displacement is little greater, more and more, but at the open end it has the maximum displacement, the maximum amplitude of the particle here. So we have two nodes here. It means at this point and at this point we have the zero displacement, but for antinodes we can have the maximum displacement. Hence option C and D are correct for this particular length. This is the complete length, L. So here we have the node. Yes, for formation of nodes, it means the displacement is 0 at this point, means this particle was initially moving in this way and this way. So here's this way and this one. So look at the formation of this node, means the wave on the either side is moving towards each other to make the zero displacement at this point. So if we compare this arrow with this one, if we compare these two arrows, they have the same direction. It means we have, and for these two the directions are opposite, but still the amplitude is positive over there. Look at here and here and here and here. So nothing is to be required to reverse the amplitude, means wrong. So option A is correct. So always the amplitude is positive, it's not going to negative at any point. So for the diffraction is shown over here in this question. You know that to get the maximum diffraction, this gap means this wavelength must be comparable with this gap. So here the diffraction is not maximum because the gap is wider as compared to wavelength. So if we make this wavelength a little more, we can have the maximum diffraction, because then this bigger wavelength is comparable with this gap. So if we have to decrease the wavelength, that is f is equal to v by lambda decreased and the wavelength is increased. So if we increase the wavelength, that wavelength is comparable with this gap, we have the maximum diffraction. So more diffraction means option B is correct here. For this, observable interference fringes are produced using the light from a double slit interference experiment. The intensity of the light emerging from each slit is initially the same. So it's like this one, and this one. We have the fringes over here. The intensity I is same. Okay, the intensity of the light emerging from one of the light is now reduced. This intensity is now reduced. How does this affect the interference pattern? What happened with the interference pattern? By reducing the intensity, the positions of the bright and dark and their gaps remains the same, because you know that x is equal to lambda d over a. This a, this d, and the wavelength is not going to change, so this x is same. But there is some difference, because when these two intensities are going to add up somewhere, means for example the intensity is say 4 from this gap and 4 from this gap, the resultant intensity is 8, that is 4 plus 4. At destruction, this is 4 minus 4, the answer is 0. But if one of the intensity is reduced, means this is 4 plus 2, it is 6, means it become darker from bright towards darkness. And here it's 4 minus 2 is 2, it means it's moving towards the brightness. Now how does this affect the interference pattern? The bright fringes become darker and the dark fringes become brighter as shown. So straight away option D is correct. Look at here, the bright and the dark fringes are all become brighter. No, the bright fringes and the dark fringes all become darker. Straight away these are wrong. The bright fringes become brighter and the dark fringes become darker. No, the darkness will not increase because they are not going to have the value less than 0. So the maximum darkness at 0. So this is wrong as well. Option D is correct. In this question number 30. Okay, the diffraction grating has lines 4 into 10 to the 5 lines per meter. The beam of light is 5, 8, 9, 10 to the minus 9 incident normally on the grating. What is the angle between the second order maxima and the diffraction of the incident of the beam? Means if we have the screen like this one, this is the 0 order and this is the second order. Yes, second order. The beam of light is normally on the grating. What is the angle between the second order? Yes, if this is second order, then this theta is required. So you know that the formula is d sine theta is n lambda, and you may write as sine theta over capital N is n lambda. So sine theta over n, the n is 4 into 10 to the power 5 lines per meter. So the unit is correct. It is second order and the wavelength is 589 into 10 to the power minus 9. So this theta is your answer. By solving these calculations on the calculator, you can have the answers written somewhere over here. Yes, it's C. A simple question. So for question number 31, look at here. Okay, this is a length of wire RS. The cross-sectional area is A and A by 2 shown at R of the wire. The cross-sectional area is A and here the cross-sectional area is reduced. You know that there is a reduction in the cross-sectional area, but charge Q takes time T to pass through the wire at this point. There's a constant electric current, this is the important thing, in the wire is flowing. The current is constant. It means you know that the formula is I is equal to Q by T. If this I is constant, means Q is directly proportional with T. So Q charge is flowing when the time was T. When the time become T by 4, then definitely charge should be Q by 4. Straight away, option B is correct. Here for question number 32. There is a power supply, means this is the power supply, and this power supplies may be attached with some resistors or thing like that, and okay, with the connecting wires, these wires having the resistance of 4.9. The power supply has output power of 3.6. It means it's 3.6 watt the power, and the terminal potential difference is 12 volt. This is the terminal potential difference. Okay, how much thermal energy is dissipated? The energy is dissipated in 1 hour in the leads in the wires. So we have to use this resistance. This resistance is the resistance of these wires, which are indicated in this way, it's bold one. Okay, so by using the relation P is equal to VI, we can find the amount of current flowing through these wires, this current. So it is 3.6 into 12 into I. So the current is 0.3 ampere. So to get the energy, that is energy is equal to power into time, that is I square R into T. I square is 0.3 square, the resistance is 4.9, and the time is 1 hour, means 3600. So by solving this, you can have the answer. The answer is written here, and the answer is 1.6. So option C is the correct one. In question number 33, you have to write the diameter of the alloy wire and the copper wire. Initially, a copper wire is replaced with the aluminum alloy wire, and same length and resistance. It means length and resistance are same. Copper has half the resistivity of the alloy. Okay, a copper wire, you have to write R is equal to rho L over A, and R over L is rho over area is pi d square by 4. You know that area is pi r square, r is equal to d by 2, so it is d square by 4. And this is for the copper, but for aluminium is equal to 4 pi d square, but you know that the copper has half the resistivity of alloy. It means the resistivity is half. So the resistivity is of the copper is half. So it should be rho by 2. Okay. Now the left sides are equal, so we may write the right sides equal with each other. This is rho 4 over 2 pi d square is equal to rho 4 over pi d square. So differentiate with these two d's. For copper, this is called d, and for this aluminium, this is called d dash. So it is d dash. like this one. Okay, now you have to write the diameter of the alloy, this one, divided by this diameter. So but just solving it to cancel on either side, so it is a 1 over 2 d square, and this is d square dash is equal to 1, so d dash square by d square is 2 by taking the under root on both sides, so this is d dash by d is equal to under root 2, so option A is correct. Just a simple question, just you have to make two relations and compare it. In question number 34, we have three identical lamps, that is PQ and R, PQ and R, connected with a battery of negligible internal resistance. Here, right, the filament wire in lamp Q breaks, so it's going to break and no longer conducts. What are the chances in the brightness of P and R? So now this diagram is like this one, it's like this one, R and P. So look at the new diagram. When these two lamps are parallel with each other, and now there is just one lamp, means the resistance increases. When you put the lamps or any resistors in parallel with each other, their combined resistance decreases. But here you make it unparallel, means its resistance is now increased. When its resistance increases, its voltage increases. So its voltage decreases, so that the sum of these two voltages must be equal to the EMF. Hence, for this lamp P, the voltage increases, so this lamp become brighter, and for lamp R, the voltage decreases, so this lamp become dimmer. For P, the voltage increases, so the brightness of P become brighter, this and this. It's become dimmer, so option B is the correct answer. Next question, number 35. In this question, you have to write the units of EMF. You know that EMF is W by Q, that is joules per coulomb. So joules per coulomb, that is actually the energy transferred per unit charge. Energy transferred per unit charge, option C is correct. Now this question number 36. Here this is a type of a Wheatstone bridge here, but the most important thing is that the voltmeter shows 0. Voltmeter shows 0 means the voltage of this 2 and 5 is similar, while the voltage of this 10 and the combined voltage of R and 8 are similar. When there is no voltage difference, means no potential difference is shown by the voltmeter. We may draw this diagram in this way. Look at here. This is two resistors attached like this one. It's like this one, and this is voltmeter, and another resistor is attached over there. So these two resistors are parallel, and if there is no potential difference between these two, so the voltmeter shows 0. But look at here, if we consider these two parallel resistors a single one, then they are considered to be in series. We can apply the potential divider, and these two are in series, so we can apply the potential divider. So first of all, I'm going to find the voltage of this resistor. So for this resistor, the potential, by using the formula of the potential divider, it's 2 divided by 2 plus R dash. R dash means the combined resistance of these two, multiplied with the EMF. So for this one, the voltage is 5 over 5 plus 10 into E. As the voltmeter shows 0, so these two voltages are equal. It means 2 over 2 plus R dash into E is equal to 5 over 15 into E. So these E's are now cancelled. So you can have 30, 10 plus 5R dash. So it is 20 by 5R dash. So it's 4 ohm. It means the combined resistance of R and 8 is 4. So they are parallel. So we may write it as 1 over the combined resistance is R dash, which is 4, is equal to 1 over 8 plus 1 over R. So by solving this, the answer is 8 ohm. This is the correct one. Without calculation, you can solve it as well. For example, if two resistors are similar, then their combined resistance become half of one of the resistor. If its resistance is 8, then its resistance must be 8, so their combined is 4. Moving towards question number 37. In this question, for example, here these two resistors are in series and these two are in series as well. Suppose this is 6 volt and all these resistors have the same resistance initially. So if it is 6 volt here, then it is 0, and it is 3 volt at this point. So the difference is 6 minus 3 is 3. Here the difference is 3 minus 0 is 3. Similarly here it is 6 volt, it is 3 volt, and it is 0. So according to this arrangement, this voltmeter shows 0 value because the potential on both sides is same. But in this condition, a weight change on its own will cause the voltmeter to show the more positive. More positive means the voltage at X must be greater than the voltage at Y. If the voltage at X is greater, it is positive. The reading is positive. So here we want to increase this voltage here against this resistor. We want to increase this voltage, we have to increase the resistance. So you know that when more light shines on it, its resistance decreases. When less light or low light, less light shines on it, it means when more light shines on it, its resistance decreases. Less light means the resistance increases. If the resistance increases, the voltage increases. So initially, suppose the voltage was 3 here, 6 minus 3 is 3, but now voltage increases to become maybe 5 volt, okay, 5 volt. Then this should be 1, so 6 minus 1 is 5. Now again compare these two values. Here this voltage at X is greater than at Y, so it becomes positive. It means we have to increase the voltage and resistance by making the light intensity lesser on this LDR. Look at here, you have to change the intensity. Reduce the intensity of light incident on the LDR means reduce the intensity means less light. So option C is the correct one. Look at here for question number 38. There is alpha of the hitting on the gold nucleus and deflections greater than 90 degree means this is the topic is related with the gold foil experiment. Here, for example, one of the alpha particle comes here and going to move in this way, going back. It means the direction is going to reverse. Which property of the alpha changes as a result of this reflection? Means the direction is reversed, it means the momentum is going to change. So option B is correct. There is no variation in the charge, nuclear number, proton number, only the variation is in the momentum because the direction is going to reverse. For question number 39. You have this uranium 23892 decays by having the alpha and beta both are going to decay and make this 206 and 82 of polonium. It means initially to get this alpha we may change this number from 238 to 206. So to get alpha 42 here, this PB is required. So initially it's something, it's a star because we have no idea initially. We want this value reduced from 238 to 206 initially. So if we have subtraction of 32 from 238, we have 206. So if we have 8 alphas, then 4 8s are 32. It's become 206, and 16 is reduced from 92. 92 minus 16 should be 76. Okay, so 8 alphas are required. So to get the beta, there is no variation in this. So for this 206 and 76, to get PB 206 and 82, this is beta. So this 206 remains the same, so we have to get this 82 from 76. So how many betas will come out? It's 6, and yes, it's 6. So by having minus 6, 82 give you 76. So option A is the correct one. So for this last question, which list of the particle contain only fundamental, the fundamental one? Fundamental particles means the particles which are not made from the other particles. Here option number A is wrong because mesons are not fundamental. Mesons are made from 2 quarks, so it's wrong. Here the baryons wrong, and alpha not fundamental wrong. Here definitely it should be correct because all there are wrong. So here the leptons, yes. The basic particles, the quarks are big, the positrons are basic. So option D is correct. And thank you very much and good luck. Hopefully see you soon with the new paper. Thank you very much. Bye.